In this video, we're going to explore files and exceptions. So, for a program to retain data between the times it is run, you must save the data somewhere. You can save it on a disk, you could save it on a database, all sorts of things. But data is saved typically to a file. Saved data can be retrieved and used at a later time. Writing data to is what we call saving data on a file. An output file is a file that data is written to. So basically, data is copied from RAM to the file and in different places on the file. Disks are organized in various different ways depending on the type of disk you might have. Reading data from is the process of retrieving data from a file. An input file is a file which data is read from. So there's 3 steps when a program uses a file. Open the file, process the file, and close the file. If we don't close the file, we will run into the operating system limits, so we can't open it anymore. So similarly, just like the input, the output pulls data from the disk. So in general, there are 2 types of files. Text files containing just text, and binary files containing data that has not been converted to text. There are 2 ways to access data stored in a file. Sequential access, which is it reads sequentially from beginning to end and it can't step ahead. Or direct access. You can jump directly to any piece of data in the file. File name extensions are short sequences of characters that appear at the end of a file preceded by a period. And you typically indicate the type of data stored in the file, like .txt, .java, .py. A file object is an object in code associated with a specific file, and it provides a way for a program to work with the file. The file object is referenced by a variable. So here would be a variable named file object, and it points to a file on disk or other storage. So opening a file, we use the open function to open a file. It creates a file object and associates it with a file on the disk. The general format is file object, open, give it the file name, and then mode. Mode specifies how the file will be opened. You can open it for reading, writing, and appending. Okay. If the open function receives a file name that does not contain a path, it assumes the file is in the same directory as the program is in. If the program is running and a file is created, it is created in the same directory. You can, however, specify an alternative path and file name in the open function. You can prefix the path string literal with the letter R. So let's first look at writing some data to a file. A method is a function that belongs to an object and it performs an operation using that object. The file object's write method is used to write data to the file. File variable.write. When you're done, you should close the file. Similarly with reading, the read method reads the entire file contents into memory. This only works if the file's already been opened. The contents are returned as a string. Read line file object method reads a line from the file. The line is returned as a string, including the new line, /n. The read position marks the location of the next item to be read from the file. How do we add or remove a new line? In most cases, data written to a file are values referenced by variables. It's usually necessary to concat a /n to data before writing it. This is carried out using the plus operator in the argument of the write method. In many cases, we need to remove it, and you use the strip method. When open file with a W mode, if the file already exists, it's overwritten. If you use the append node, if a file exists, it's not erased, and if it does not exist, it is created. Data is written to the file at the end of the current contents. Numbers must be converted to strings before they are written to a file using the stir function. Numbers are read from a text file as strings and must be converted back to numeric types in order to use. Use the int and float functions to convert strings. Files typically used to hold a large amount of data. A loop typically is involved in reading from and writing to a file. Often the number of items stored in a file is unknown. The readLine method uses an empty string as the sentinel when end of file is reached. Can write a while loop with the condition while line doesn't equal empty string. So here's a general flowchart. Open the file. Use read line to read the first line from the file. Did it return an empty string? No. Process the item. Read another line, and so forth. And if it returns yes, close the file. You can use Python's for loop. Python allows the program to write a for loop that automatically reads the lines in a file and stops when end of file is reached. For line in file object statements, the loop iterates once over each line in the file. Processing records. A record is a set of data that describes one item, one single item, like a person. A field is a single piece of data within a record, like address. We write records to sequential access file by running the fields one after the other. Similarly, we read records from the sequential access file by reading each record until complete. When working with records, it's also important to be able to add records, display them, search, modify, and delete records. Let's touch briefly on exceptions. Exceptions are errors that occur when a program is running. It usually causes the program to halt. A traceback is an error message that gives information regarding line numbers that cause the exception. It indicates the type of exception and a brief description of the error that caused the exception to be raised. Many exceptions can be prevented by careful coding. For example, validate your input. Make sure they're in an appropriate range, etc. This can be done with a simple if or while. Some exceptions can't be coded. For example, trying to convert a non-numeric string to an integer or open a file that doesn't exist. An exception handler code that responds when exceptions are raised and prevents the program from crashing. In Python, we use a try except statement. So the format is try, do some statements, except the exception name, and then do some more statements. The try suite statements that can raise an exception. The handler are statements contained in the except block. So the handler handles the exception. If a statement in try raises an exception, the exception is specified in the except clause. The handler immediately follows the except clause and executes, and it continues programs after the try except statement. If other exceptions that aren't trapped, the program halts with a traceback error. If no exception is raised, the handlers are skipped. So sometimes we have different types of exceptions. You need to write an except clause for each type of exception. An except clause that does not list a specific exception will handle any exception. So it should always be the last, because basically you go from most specific to least specific. Okay. Displaying an exception's default error message. An exception throws an object created in memory when an exception is thrown. There's actually an object. Usually contains the default error message pertaining to the exception. You can assign the exception object to a variable in an except clause. For example, except value error will trigger when a certain type of clause written. You can pass exception object variables to the print function to display the values. Try statements may include an optional else clause which appears after all the except clauses, and it's aligned with the try and except clauses. It's similar to syntax to else. The else suite is a block of statements executed after statements in the try suite only if no exceptions were raised. So basically, if everything went fine, raise the exception. Don't raise the exception and use else. If exception was raised, the else suite is skipped. This is similar to the finally clause in other languages, except that it only executes when your code succeeds. There is also a finally clause, which may include an optional finally clause, which appears after all the except clauses. It's finally statements, and it's always executed, even if an exception does occur. And the idea is to clean up after yourself. What if an exception is not handled? Well, no exception clause specifying execution of the right type. The exception will be raised outside a try suite. In both cases, unless it's caught higher up, the exception will cause the program to halt. So now we're going to demo some of these things and play with the code a little.